All right, thanks everybody for coming. As the slide suggests, what you need to know about the future of Fibre Channel. It's myself and Howard here. We're representing today the Fibre Channel industry. Howard Johnson is the chair INCITS Fibre Channel Technical Committee. Also works for Broadcom, formerly Brocade. And myself, I'm Mark Jones. I am representing the FCIA, the Fibre Channel Industry Association. And together we're going to give you an update of what's new with Fibre Channel, where it's been, where it's going, where things are working well. And of course, we want to get everybody's feedback on what you're hearing and what you'd like to say to us. Just a brief agenda. We don't have too much time, so we're going to keep everything pretty high level and go over quite a few different concepts. But this is kind of the general flow of what we're going to talk about. Just to give you all a little bit of background, Fibre Channel, I mean, you probably remember it goes back into the 90s. We have data that we've been tracking since 1998, so we have quite a few statistics and numbers. The FCIA itself is on its 30th anniversary, so you know the marketing part of Fibre Channel has been around for a long time, and you know we probably look like it too with gray hair and all. So just give you some background on some of the numbers. You know, it's still a very profitable business, Fibre Channel. You don't hear about it a lot because everybody wants to talk about AI and Ethernet and InfiniBand and everything else. But what's really powering the data centers, the connection to storage, is still a lot of Fibre Channel. And because a lot of enterprises have a lot of structured data and they need that super reliable connectivity to storage devices. And because of that, you know, we have a tremendous record. These are all numbers kind of looking back from the 1998. So over 50 billion in Fibre Channel revenue. That is just the cost between the manufacturers of Fibre Channel components and the wholesale pricing as it goes into the various areas where they get distributed, the products. On the right side, the total number of Fibre Channel ports, we're well over 160 million ports that have been shipped since the early days. And if you just look at the last 5 years of how many ports have been shipped in the last 5 years and kind of look at that as that's probably the installed base that's capable of being connected today. That's 35 million ports. That's a lot of ports of storage connectivity that's out there using Fibre Channel. So you may wonder why, with all this talk, why is Fibre Channel such a good thing? And there's a lot of really inherent, basic capabilities that Fibre Channel has that nothing really does quite as good at. Number one, it's designed for storage. So its roots all have to do with replacing SCSI and replacing some of the direct attached connectivity from the very old days. And Fibre Channel was designed to do that. Security, well, Fibre Channel is really an air gap network. It's not Ethernet. You can't really hack Fibre Channel from the outside in. It's very difficult to do that. So it has an inherent natural security built into it because of that, because it's locked into the data center. It has other features like real hardened zoning. And of course, Fibre Channel is very famous for its fabric services and its extensibility to manage the vast network that it can create. And we never rest, and we're always working on the new updates for Fibre Channel to enhance security. And there's a lot, as you probably know, going on in governments to make data center security even more stringent. We're responding to that with the new FCSP3, the security protocol. We'll talk a little bit about that. But the bottom kind of keynote there is encryption will be everywhere. Everything's going to get encrypted with SP3. High performance, you probably don't realize, but Fibre Channel is actually very low latency. It can be sub-single-digit latency numbers from Fibre Channel, as low as. It has pretty low CPU utilization due to being controller-based. And of course, very high IOPS. And then also, Fibre Channel has very high fabric utilization characteristics. So you could run a Fibre Channel network at the very top of its utilization without any kind of loss of performance or loss of data. And then reliability, resilience, it's lossless, credit-based. It's designed with a very, very low bit error rate, much lower, much more stringent than typical network standards. And of course, everything's about investment protection. So if you bought the latest, greatest fiber channel today, let's say it's 64 gig products are shipping today, you can still plug it into your 16 gig switch if you had it, or plug in an old storage array into it. So it allows that cycle of continuous upgrade to take place naturally when capital expenditures need to be processed through. And of course, cable plug compatibility. Okay, just we always want to talk about the speeds, and there's been a lot of generation of fiber channel speeds. The way we manage that within the industry is with the fiber channel roadmap. We've been maintaining a roadmap since the very beginning. I think we kind of said it started with 1 gig. There were actually products before 1 gig, partial speed products. But this is the roadmap in its modern view. We are shipping 64 gig fiber channel today in very large numbers. We're very much coming up on the next transition speed of 128 gig fiber channel. And then we have a roadmap looking forward from that. And of course, these are all single lane speeds. So I think when you think about Ethernet, there's a lot of 200 gig, 400 gig, which are actually multi-lane speeds based on a number of single lanes put together. This is all single lane speeds. So with that, Howard's going to talk a little bit more about what's coming up, right?
You bet. We've just finished our 128 gig specification, and there are 5 characteristics that we always look at each time we do a generation for fiber channel. The first one is throughput. Essentially, the fiber channel is always trying to double the throughput from the previous generation. The second one is error correction. Mark already touched on that because our tolerances are very, very stringent with regard to what level of bit error rate that we're going to tolerate for storage networks. And it's because it's storage is why we have such a high threshold. Compatibility, we touched on that as well. There's always from a requirement specification, we always indicate that the current generation must be capable of stepping back at least 2 generations in order to maintain that backwards compatibility, which is useful for all of our install base and for our customers to be able to make transitions as they can over the life cycle of their products. Distance, from a distance perspective, we have kind of a broad range. For the short reach kind of stuff, we're looking at 100 meters. These are internal data center distances. And then for single mode, we're out to 10 kilometers as the distance piece. So it's kind of a broad range that we're trying to drive this signal out fairly short at 100 meters and fairly long at 10 kilometers. And then finally, reuse, which is be able to reuse the connector capability. So SFP Plus has been the connector of choice, and we've been able to use that form factor over several generations. We have the milestones for 128 gig. We finished I'll just go through the specifications. The physical interface specification, version 8, is the 128 gig specification. It was completed in October of 23. So many of the vendors in the fiber channel community have already been working on that technology. And in fact, we expect, as Mark's previous slides show, 128 gig products to be available later this year. The framing and signaling specification, revision 6, was also completed at a similar point in time. Those 2 specifications go together. And then lastly, the kind of a look into the future. Immediately after completing 128 gig, we began working on 256 gig fiber channel, which I'll talk to just shortly. As we rev up, same set of requirements that we have for each generation: throughput, error correction, compatibility, and then distance. This is the one I wanted to spend a little bit of time on because at single lane signaling at 256 gig, we're starting to run into various issues associated with managing or being able to clock those signals. At 100 meters, it's very difficult for us to get that kind of distance. The fiber channel community and the IEEE community have been working a lot together on being able to do this. Because IEEE's spectrum of products is so wide, they are able to tolerate distances more like 30 meters versus wanting to get out to 100 meters. So what we're looking at on the multi-mode fiber is actually using a bi-die approach. Essentially, we're going to use both fibers that are in the wire to transmit and then using a different wavelength for the receive side. So it'll effectively be a 2-lane solution using the physical cabling that we have installed in data centers today. So that was one of the biggest challenges that we needed to get over with regard to the definition of the 256 gig specification. Final note there being that it's underway. We are very, very close to getting to the point where we're at completing, I'll call it the base draft, and getting into the phase where we'll start going through the committee review and the member review. Expectation is that we'll have the specification completed for public review by the end of next year.
Okay, NVMe over Fibre Channel, or NVMe over fabrics with Fibre Channel. You know, we started working on that from the very early days. I think it goes back, the T11 group started in 2014 or so, and that was the mapping of Fibre Channel to the NVMe fabric specification. We've been through lots of milestones, including lots of plug fests, lots of work, lots of iterations of the spec. And you know, we're at a point in time where Fibre Channel is virtually shipped by almost all manufacturers of Fibre Channel equipment and storage devices, more so than probably what you're thinking of other transports that are often thought of as being NVMe over fabrics. So Fibre Channel is actually very pervasive out there using Fibre Channel, and we have a lot of data, a lot of information that really show that the performance benefits are very significant, especially for high transaction type applications. So we're continuing to refine that with new versions of the NVMe, FC NVMe specification.
In addition to the various speed bumps that each generation of Fibre Channel supports, we also implement different types of improvements in the protocol. One of the more recent improvements that we've added is something associated with fabric resiliency. So one of the problems that you run into in an air-gapped type of configuration, like shown here on the slide, is that if you have a particular link that is slightly faulty, meaning it fails once in a great while, but it seems to be fairly persistent, they're really hard to figure out. The other problem with that is they have a pretty dramatic impact on the overall performance of the system. So isolating those links relatively quickly is important. One of the causes of this is typically marginal cables, or SFPs, or any type of connection issues. We used to go through and do a lot of cable cleaning during the early days, and I still encourage that with customers today to make sure that their connections are solid. But these can be the sources of these, I'll call them persistent intermittent problems. The Fibre Channel community has really evolved to the point now where all of the components in the system are very good at being able to identify these things. So what we needed was, this is the next slide, was an ability to take that detection capability that's inherent in the various parts of the system and communicate that information out to the other parts of the system. So in this example, the switch might identify a particular link as being marginal, so now he can tell both the storage device and the server device that this is, in fact, a marginal link. In the case of a multipath solution, the server can actually move or shift that workload away from that faulty path, isolated path, and therefore maintain a much higher throughput in the overall system. Another development that we've started on, and in fact I'd like to point out our editor, the FCRDMA editor, Dave Peterson, has been a champion of bringing the RDMA over Fibre Channel to life and reality. So we've completed the specification and it's currently in internal review, and we expect it to complete public review in the next couple of months. Probably in December or April we'll have a completion of the RDMA specification. But the intent here is to demonstrate that Fibre Channel can provide a transport for the upper layer protocols such as RDMA and take advantage of the inherent characteristics of the Fibre Channel hardware.
It's yours.
Okay. I'd also like to point out our chair of the FCSP3 spec, Roger Hathorn, back here. This has been a complete revamp of the security protocols for Fibre Channel. The intent really is to align ourselves for the CNSA 2.0 requirements and to be able to offer a more effective solution in Fibre Channel for the various security protocols that are evolving. Our challenge here really had been, how do we shrink the SP2 specification into something that's much more functional for where security is these days. We've completed this work and are currently in internal review and expect to go to public review later this year and ANSI publication by our April meeting cycle.
Yeah, there's actually a really important use case for this. And as we mentioned earlier, security is becoming super important. There's lots of new government regulations that are going to mandate people using encryption more and more. And we've already seen that with the server manufacturers, where they're really building up a zero trust architecture. And now that you have that, you have zero trust on the hardware side, on the server. For us, you have the devices, you have signed drivers and firmware that can't be hacked. You have the actual CPU to HBA attestation requirements that are encrypted, and it really creates a whole silicon root of trust. When you have that kind of environment on both ends of the wire, and you have a new FCSP3 specification that has the algorithms for encryption at the highest level, like CNSA 2.0, what you now have is the capability of two trusted ends that can be its own. You can have manufactured certificates on each controller on either side, and now you have the ability to, as when they log into each other, there is a sense of an automatic trust between them, and a encrypted session can be established. So if you think about that for a minute, when you see that kind of devices on storage devices, and now the new servers shipping with these capabilities, with HBAs are capable of this, all connections in the future are going to be automatically encrypted. The possibility is out there, and that's a great thing for Fibre Channel. As I mentioned earlier about security and why people look to Fibre Channel naturally for being a very secure network, this enhances that even more. So it's a real good use case and example for that. And then kind of finally, the last thing, everybody's talking about AI at the conference this week, and Fibre Channel shouldn't be overlooked in the concept of AI, and it's a natural that it will be used in its form today, because, like I said, almost all structured data is carried over a Fibre Channel network to a storage device. And what enterprises are doing now is there's a rush to bring AI into the data center, into the companies. And companies are not going to build gigantic LLMs themselves, right? They're going to try to make their data smarter, bring various different types of data together, and the use of what's a lot of companies have termed the AI factory means that they're going to use methods like RAG, retrieval automated generation, and vector databases. We're seeing lots of database vendors now, their new offerings all have vectoring capabilities. Those two things together means that the data is going to be stored again over Fibre Channel, but this time with now a lot more information in it. We're seeing estimates as much as, in the basics, 4x the size of the data growth expected on Fibre Channel. And you heard Jay earlier today saying it could be many, many times more than that. So it's a very good and strong thing for the Fibre Channel industry, I believe. So with that, just a couple things. One other aspect of the FCIA is we like to provide education to people that are out there. We realize that not a lot of young people are learning the individual details about Fibre Channel in school. So we kind of bring the history and the education together, and there's a number of resources that we have. We have a Bright Talk channel with lots of industry experts talking about Fibre Channel and very specific things about the specs. Also have a YouTube channel where a lot of that's translated into there for easy access. And we encourage everybody to join the FCIA, look at our resources, ask us questions. We would love your participation if you're an expert here as well. So fibrechannel.org is our website. We encourage you all to go there. So with that, I'd like to before I ask for questions, I just want to thank you all for attending, and please, fill out the conference review for us and give us a good rating. And with that, is there any questions from the audience that we can answer? Come on, please.
And just I'm at Cisco, so we also do Fibre Channel. My question is, I'm perplexed about the speed with the Fibre Channel and the timing of it. As you mentioned that 256 is running into problem with doing the BiDi and all that because of the single lane architecture. So rather than going BiDi, should we try to move Fibre Channel into parallel lanes back, because if we do that, then 64 times 4, we can already get 256 today. So which one will be more cost effective moving forward? Because terabits ain't going to happen on the single lane, so it's going to kind of end at BiDi, going forward. It'll be much harder, So what's your thought?
They tried that Gen 6.
Yeah.
What does that say? Is it automatic the wall?
It worked just fine, it's just nobody did it.
Well, there are also licensing issues that made it impossible to reach.
You want to summarize that for the...
Yeah, so the question was basically, why not go back to parallel instead of BiDi? So I'll answer this in two ways. The BiDi solution only addresses multi-mode. Single mode, we still have the capability of getting single lane, and we probably will start investigating various specifications for different forms of single mode, like 500 meter, 2 kilometer, 10 kilometer specifications. The second part of the answer was really brought up by the gentleman back there. I'm sorry, I don't know your name, sir.
I might know him from Abbott Labs, but the SFP Plus is a very stable form factor. And if you look at MTP or anything else like that, it is a very dynamic environment. So the connectors that are being proposed for very high bandwidth networks inside of data centers and hyperscalers, it's almost impossible to invest in something that you think is really going to be around in 5 years, much less 10. So SFP Plus, I could live with that, and then just, if I need greater than 30-meter distances, I go single mode. There's a lot of single mode coming into enterprise data centers now. Even between, ISLs between Cisco networking switches, my networking guys, the Ethernet guys are demanding single mode. Between switches, single mode, always.
That's great to hear. I expected that. My background is in mainframe, so it's been single mode forever. So, so yeah, that's wonderful to hear. But Roger mentioned earlier, the market didn't buy into the quad lane solutions that we had.
And Howard, we also have to balance we like to make things backwards compatible and plug compatible and all that if we can. Maybe we're in a box and we have to change, but we've done very well by having this capability of having a natural upgrade path due to the backwards compatibility capabilities. Any other questions?
So I see SPDM attestation between the CPU and the HBA. Any thoughts of bringing it out to the devices? It's now available to you as DSP 0286.
I'm not sure I know the answer to that. I think it's a great idea. I don't know. I really don't know the answer. But yeah, that's something we have. It's actually, we're hearing more companies requiring that capability, SPDM 1.0 at least.
For what it's worth. Recently, T10 has built in proposals which extend SPDM into the device.
Yeah.
You can start using it.
Excellent. Good question. Yes, sir. Here's the mic coming.
So speaking of SFP Plus, we're currently a little bit in a conundrum right now where we'd like to advance forward working on the SFP Plus for... Oh, I'm sorry. The we is the SFF technical work group. So the SFF technical work group, not we, is looking at working towards SFP Plus for the next generation, 224, 256, et cetera. The problem right now is trying to get interest around getting that spec developed, because there is there's a delay right now. And one of the things we're running into is IEEE's finishing their spec, and SFP is threatened to not be listed potentially in that next spec because we don't have any connector working at 224 for SFP+.
Is it a priority thing or an interest thing?
That's a good question.
Or is it a communication thing between
And
the two
it
groups?
could be, yeah.
A lot of the same people.
Well, and one of the things I'd like to see is almost like a call to action to let's start the work on 224. We've got the project open in SFF now, but let's get the connector work go, or the transceiver work going such that we can get that spec out and get a good draft out pretty quick. So that's my request out to the Fibre Channel
Yeah.
community.
Howard, do you have any thoughts on how, with the way
Yes.
INCITES runs and our meetings and all?
During our last meeting, Tom Palkert also made the same request. So it's really a call to the member groups, member companies to provide input and get involved in the 224 spec. Yeah. So that's we'll make the same call out at our December meeting and try to continue recruiting folks from the Fibre Channel community to address this.
Because we need help. We need help pushing.
Need help pushing.
Thanks for raising the
Note-taking.
awareness of that. That's a good question. Any other questions? We're just about out of time.
I just have a quick, just a consensus to see if 128 gig speed, where do we need it? Because there's nobody, no storage arrays,
AI, man,
128.
you heard me, 4 times.
So
Storage is going
AI
to explode on Fibre Channel. We're going to need more speed.
AI will never take Fibre Channel, right? Because Jensen is not going to buy into certified Fibre Channel
Don't confuse
adapter.
ingest with the enterprise, though. I think that's 2 different subjects.
Yeah, mainframe might do that, right? So with the FICON and all that thing. But for the, I'm just curious, because do you know when the storage arrays will come out with 128?
Yeah, that's a really good question. Historically, what we've always seen is that the fabrics tend to lead. So the infrastructure comes in first, and the HBAs roughly a year later, and that brings in the servers and some of the early storage, and then storage is usually 2 to 3 years after that. And that's kind of the typical cycle that we see when.
3 years from now?
Yeah, 3 4 years.
You'll get one company it's the right time for them to just add it, especially if the switches are available and controllers are available, and then once one guy gets it, then everybody's going to want to adopt it. So it's kind of a race to have it then. So.
Doesn't it really depend upon the kind of controller architecture? If you've got a big iron company that has a controller architecture that's several years old, that's going to take several years for them to just get bus inside of that controller. But a smaller company that has more white box approach to their controller and concentrate on software so that they can bring in PCIe 6 or 7 into their next generation of white box, they're going to get there a lot faster. So it really depends upon the architectures of the storage arrays that you're talking about. Some will be fast movers. Others will be, turtles who may not win the race.
Yeah, their development cycles are longer.
2 to 3 or 4 years to truly get the benefits of 128 gig end-to-end.
It's like all infrastructure, one part has to lead, right? But and it's another reason why you have 3 speeds that you can host in Gen 7 or Gen 9 to reach back down.
Hey guys, why don't we cut it here and you guys can talk in the, having a beer.
Perfect. Thank you.
That's a good idea.
Thank you, Steve.
Thank you.
Thanks, everybody.